A very basic two-dimensional plot can be produced in 4 simple steps. We import the module pyplot, which contains all functions needed to plot and modify a graph. The module is usually imported with the plt alias. I mentioned this step first because it's always located at the top of the code. Of course, you may need to import other important modules such as NumPy. All two-dimensional plots require data as xy points. These points are prepared for plotting as an x array and a y array. That's why both arrays must have the same length. The data points could be resulting from a mathematical equation or a formula, or from readings of measurements from a lab experiment or any other application. For example, let's say we have values from 0 to 6 in 20 points. Now we can compute y as, for example, square root of x. The third step we call the function plot, and the very basic form of the function receives 2 arguments, the x array and the y array. The last step is to send a display command, show, to open a new window that includes the plot. The graph window has some useful tools. The first is the zoom tool to magnify a part of the curve. The home button takes us back to the original view. We have these arrows forward and backward according to the changes we made before. We have the pan, so we can move the graph inside the window according to the view we like to show or save. Also, we can save the graph as an image file or PNG file. Notice that we cannot edit anything on the idle shell until we close the window. We can add the y computation directly to the plot function in this way. We got this plot again. A third argument can be added with a small string that specifies the properties of the curve. The default is blue continuous line without markers. So this text or this string will result in a red dashed line with circular markers. Let's test it. These tables of the color and style codes in pyplot, and you can find all these tables in the PDF handout uploaded with this lesson. The plots we have seen so far are too basic. We need to add some more information. First, we can add labels to the axes by using the X label and Y label functions. Basically, they take the label as string. That's why I typed the word label in green. Let's try it. It will return a text of the coordinates of the label on the figure and the value of the label itself, like X and Y. Now, we always add show at the very end. So that means any modifications, any additions must be before the show command. So as you see here, we added the X label and the Y label on the axes. Now we can control the locations of the labels by using the argument lock. So the argument lock for X label controls if it is in the center, which is default, or at the right or the far left of the axis. Similarly, for Y label, the default value is the center, but we can move it to the bottom or the top of the axis. Let's try it. So as you see here, the X label is moved to the right, while the Y label is moved to the top. Also, we can add a title at the top of the graph. So the title could be added as a text to the function title. Again, we need to make the plot. Then square root function. Then we can print the labels and then show. So as you see here, the title is written at the top and at the center of the graph because it is the default position. Similar to the labels, we can also control the location of the title. One of the most important visual aids with any graph are the grids. The grid lines help the reader to understand or to estimate the values from the graph. For example, the grid lines are added at the tick points or at the values on the X and Y axis. We can control X or Y grid lines or both. So for example, so as you see here, we opted to show the Y grid lines. So for that reason, it's showing now horizontal grid lines connected to each Y value.